Hey guys, today I want to talk to you guys about Kerberos. Kerberos is a authentication protocol invented by MIT way back in the 1980s. And what it basically is a way for secure communication within a network. So in this video, I'll first give you guys a really broad idea of what Kerberos basically is doing, and then I'll dive a little deeper into it. So to get started, in Kerberos there's something called a realm. So realm will be your network, the local network that you're trying to authenticate. So it can be your house, it can be your office, so that's realm. And within a realm, there is something called KDS. And what KDS stands for is Key Distribution Center. And within a KDS, there's two servers. And one of the servers is the authentication server, and the other one is the ticket granting server. And the KDS is basically where all the magic happens. A client would talk to the KDS, and the KDS will in turn talk to the servers. And this is really high level, but yeah, I'll go. And how just everything happens is a client would authenticate itself with the authentication server, and the authentication server would then give something to the client where it will use to authenticate to the ticket granting server, and the ticket granting server will then give something back to the client where the client can use to talk to the servers, and the servers would then talk to the ticket granting server to make sure that the client is what he said he is. And so yeah, that's really high level, but I'll get started on the first process. So the first process is the client talking to the authentication server. So within the client will basically send information to the authentication server, and the information would contain the client's user ID, it will contain its IP address and a request for the TGT server. And the request is like a timeline of how long the ticket will be valid for. And right now, you just gotta know a ticket is what a client uses to authenticate itself to the servers. So, and there's a timeline for that. If after the timeline, the ticket will not be valid anymore, and the client will probably have to re-authenticate themselves. So first, the client was sent to the authentication server its user ID, its IP address, and its request for TGT's timeline. I forgot to add a timeline here. And after that, the authentication server actually has a database that contains like the IDs of like everybody in this company, and with the IDs they also will also have like a hash. So it also has like a hash of the client's IP address. So hash, and after the authentication receives this from the client, it will then send something two messages back to the client. So and the two things that the two messages that the authentication sends back to the client is, first, a message that contains information about the ticket granting server, so TGT information, and as well as a timestamp, and as well as a lifetime of the TGT that the client requests for, and finally a TGS ticket granting server session key. And this session key is really important because this is used to decrypt whatever the TGS server that will be sending back to the client. And the whole point of this is to make sure that everything is encrypted. All the important information will be encrypted. And since this one was the first message that was being sent, it's actually not encrypted because it's actually not important data. But anyways, and all of this message, it will be encrypted by the client secret key. And what the client secret key is basically a hash of the client's password. So client secret key equals client password. And since the client knows, since the authentication knows the client's password, because they store it in a database, the authentication server has the client's password and generated a secret key and encrypted the first message. And so there's also a second message, and the second message contains information such as user ID, timestamp, TGS lifetime. So TGT lifetime, so the lifetime of the ticket, and also, as well as IP address, and the name of TGT TGS server. And by the way, the first message also contains that, so name of TGS. And this message, it's actually not encrypted with the client secret key. Instead, it's encrypted with the private key of the ticket granting server. So the user actually can't open this. And after the client receives this from the authentication server, it will then send a 2 message back to the TGS server. So now the client is communicating with the TGS server. And what the client sent over is the original TGS private key, the encrypted one. So this, and then as well as like the name of the service that it wants to use. So that would be like the servers, or like a file printer. Okay. So service, and then the requested lifetime of the ticket, and then there will be a third message, and this message will actually be encrypted by the TGS session key that was generated before when the client was talking to the AS server. And this will be encrypted by the TGS session key, and it will actually have like username and timestamp. And what this is used for is to it's used for the TGS server to authenticate that the client is really who he say he is. And so the TGS will actually cross-reference these 2 messages, the first message and the message that contain the user ID, timestamp, etc. with this message. And then now, after the TGS server successfully received this message and successfully authenticated the client, the TGS server will now send the client 2 messages back. So the first message will be encrypted using the TGS session key. And within the TGS session key, it contains the service ID, it contains the timestamp, and it contains the lifetime, as well as a service session key. And the client will be using the service session key to communicate securely with the whatever server or service that it's accessing. And the second message will be encrypted using the server's private key, service secret key. And the server's secret key will contain the same information as the one from right here, like the user ID, the timestamp, the service name ID, the IP address, and as well as the lifetime of the service ticket. Okay, and so after the client receives this from the TGS server, the client will then the client will then send the service two messages. So service/server, and the two messages will, the first one will be the service secret key, so the one that was encrypted by using the service secret key. And then a second message will be encrypted by the session key, service session key. And it will only contain the username and the timestamp. And yeah, that's it. So the service will basically do the same thing as before, like decrypting this message and comparing this message. And getting the service session key from this message and decrypting this message and just cross-referencing just the message over here with the message over here to make sure the client is saying who he says, and after everything is set up, the client and the server can now start communicating, and the client can now do what he wants. And just the big idea of everything here is just to ensure secure communications, and within each step of the communication there's like a key that the client uses to talk to the next step. So the client will talk to the authentication server. The authentication server will give a key to the client that the client can use to talk to the TGS server to make sure their communication is secure. And after the client talks to the TGS server, the TGS server will give the client a key that the client can use to talk to the server securely. And one thing I forgot to mention is within each step of the process, the server and the TGS will have a cache that contains like all the previous it contains like all the previous how do I say this, like contains the previous all the previous client that has been using just sending these requests in like the past, let's say like half an hour, past few minutes, to make sure that the client has actually not use the service already. And so yeah, this is a quick tutorial on Kerberos.